What really happens when you measure a quantum state? Why is nature at the most fundamental level probabilistic? What constitutes as a measurement? These were questions I first had when learning about quantum mechanics and its relationship to quantum computing. I soon realized that despite the fundamental nature of these questions, they're not the kind of questions that physicists in the field are pondering upon. Not only that, but the whole field asking these deep questions is almost shunned from the community. They spend their time applying the rules of quantum mechanics gives them. And quantum mechanics does give you a lot of equations that you can use to an extraordinary level of precision. And scientists and physicists, we use those equations to make predictions, do the experiment, see the outcome. The rules of quantum mechanics are obeyed. But the problem is, we use quantum mechanics just like how we use our laptop. I can send emails, edit files, browse the internet. But if you ask what's going on inside or how do I build one of those, I have no idea. This is the relationship professional physicists have with the rules of quantum mechanics. So when we actually dive into these equations, no one actually knows how they work. And that's what Feynman meant by, I think I can safely say that nobody understands quantum mechanics. And right now, professional physicists from those two that I've talked to and heard have given up even trying to understand quantum mechanics. That's the problem. Because a quantum state is a probability distribution, while a classical state is either one or zero. But the thing is, when you measure a quantum state that has all that information, it just collapses down into a one or zero, just like a classical state. And right now, no one in the field knows how exactly that transition happens and what collapse into a classical state really means. This is what quantum Darwinism aims to answer. It's a complete paradigm shift, exploring the whys of quantum mechanics. And it shows what you can do when you seek to understand what others consider impossible. To quantum Darwinists, measurement is a selection process itself, and the states that get measured are especially robust in the face of disruptive decoherence or noise by the environment. So the environment doesn't squash quantumness like we thought it would, but it naturally selects some states while trashing others. And it's not only that, but when we think of receiving information on an object, it's always through the photons, right? Delivered to our eyes, scattering off of it. They carry info to us in the form of a partial replica of certain aspects of the object, like caring about its position, the shape of the object, and color. And that's what makes the classical world classical, because we can both agree that something is there. Whether you're here or here, we can both agree that the foot is right there, right? And according to quantum Darwinism, whether or not we observe some state in the quantum system depends not only on the state's robustness to decoherence, but also on how substantial a footprint it makes in the environment. More photons and other parts that carry info on that property, the likelier that that property or state will be measured. You can think of it as the environment having more of that property. So the states that are best at creating replicas in the environment, the fittest, you might say, are the ones accessible through measurement. That's why it's called quantum Darwinism, like Darwin's theory of evolution. So this is what happens when you ask good questions. If Zurich, the physicist that came up with this theory, didn't ask or question the emergence of the classical state from the quantum state, the intersection between Darwinism and quantum mechanics would not even have existed or exist. There's much more to look beyond quantum Darwinism here, though, because if Henry Ford didn't ask, why can't one team build more than one car at a time, auto production would be radically different than it is now. Or if Elon Musk didn't ask, why aren't rockets reusable, the whole landscape of spaceflight would look foreign to us. Or if Galileo didn't wonder why would the sun orbit around the earth, science might still be under the grips of the church. Good questions breathe innovation. Most people get the tools and just put it into play. This is especially true for quantum mechanics, where we know the equations and we train ourselves to match these equations to given problems. We become tool matchers. But these people have gone much further than matching tools. If you want to fundamentally innovate on a field, you'll have to know the tools. But to trigger those genius questions that cause 0 to 1 breakthroughs, you need to ask why. And so what? You need to ask good questions. And especially in an era where computers are getting better at answering questions, we need people that are better at asking questions. So, what makes a good question? A good question exposes biases, surfaces our beliefs, and exposes blind spots in our knowledge. Now, what does one need to ask good questions? Well, for one, seek to understand and not to be understood. What does this mean? Well, people are egocentric, eager to impress others with their own thoughts, stories, and ideas, and not even think about asking questions. This is tying your knowledge in with your identity. If you want to reach true understanding, you're going to have to separate those two. An attack on your knowledge is not an attack on you. When someone says you're wrong, take it as a gift. They just expose you to a certain block of your knowledge that you could improve. You're literally becoming a more knowledgeable person from it. So don't attach your ego to what you know. Most people ask safe questions that regurgitate what's already known. Good questions move the conversation from automatic reactionary thinking to deep thinking. Ask questions to move the conversation from the known to the unknown. So there's this matrix that describes the types of knowledge: unknown unknowns, unknown knowns, knowns unknowns, and knowns knowns. Most people ask questions in the red zone, stuff that we already know. That's safe and irrational. But rational questions are where you inquire on the green block, stuff you're unsure about, stuff you don't really know about. And these kinds of questions might even lend you to discover something you didn't even know existed. And lastly, be genuinely curious about the world around you. How does this work? Why do we need this for that to work? How does that relate to this? When you're genuinely curious, you won't care about boasting your knowledge or lathering your ego. You'll just have a sense of wonder, driving you to ask more questions. You'll seek to understand the why behind the tools. And with those intentions in mind, your question might even end you up among the ranks of Ford, Musk, and Galileo. Seek to understand and not to be understood. Uncover the unknowns instead of residing in the knowns, and leaving your ego aside, be genuinely curious. Now, these principles may not be a surefire way to get you to have those genius questions like Feynman, Turing, and Einstein, Ford, Musk, and Galileo. But these mindsets will, without a doubt, set the best environment for those kinds of remarkable questions to come to you. Because we wouldn't even have assembly lines if Ford didn't seek to understand continuous flow production in flour mills and canneries. We wouldn't have the reusable launch system if Musk didn't move the dialogue from a single use paradigm to where they were comfortable to where we're at now. If not Galileo letting his curiosity run free, science might still be under the dogmatic control of religion. These were the mindsets that fueled radical innovation. So I ask you, what will you do? How are you going to superpower the world? Are you going to seek to understand the causes behind algorithmic bias? Will you uncover the depths of carbon capture technology? Will your curiosity stumble you into discovering a fault-tolerant quantum computer? The future is your rocket to ride, but great questioning will always be the fuel. Thank you.
Hi, my name is Samson, organizer of TKS Community Talks. I hope you enjoyed this video. If you did, be sure to check out our channel for more insightful and inspiring talks from a community of young people training to change the world.